Hello everyone, welcome to the solution of LeetCode problem 1519 named number of nodes in the subtree with same level. In this problem, you are given a tree which is a connected undirected graph that has no cycle, which consists of n nodes numbered from 0 to n-1 and exactly n-1 edges. Now, the root of the tree is in the node 0 and each node of the tree has a level, which is a lowercase characters given in the string levels. Now, the node with the number I has the level of I. Now here, an edge array is given to the form A of B, where that means there is a bidirectional edge between the node A and B in the tree. Now we have to return an array of size n, where answer of I is the number of nodes in the subtree of the ith node which have the same level as the node I. Now here, let's consider this first example. Node 0 is connected to 1 and 2, 1 is connected to 4 and 5, 2 is connected to 3 and 6. Now here the level are, for the node 0, the level is A. For the node 1, the level is B. For the node 2, the level is A. And for the node 5, 6, 3, and 6, the level are D, C, E, and D. Okay. Now we can see that for this node 0, here the level is A. And in the subtree, it has another A here. So there are two A's in the subtree of the tree where the root is 0. Similarly, for this node 2, it has the level A, and in the subtree of this node 2, there is no node with the level A. So 2 will be marked as 1. Similarly, for the node 1, 4, 5, 3, and 6, all of the node have one of its level into its respective subtree. So all of them will be marked as 1. I hope you understood the problem statement. Now let's move on to the algorithm. In this problem, to understand the algorithm, we have taken the same example. Now here, the question is, how can we basically solve this problem? We can basically solve this problem by using the DFS. For each of the node, suppose currently we are presented at this node, we will calculate the frequency of all of the character presented into this subtree. So here for this node 1, the frequency of B is 1, the frequency of D is 1, and the frequency of C is also 1. So for each of the node, we will calculate it. And when we are returning from this node, we will simply upgrade the value into the answer of this node 1. So here, the intuition is very simple. We have to start the BFS. Currently, suppose we are at this node 0. From this 0, we can go to node 1. From node 1, we can go to node 4. Now, node 4 does not have any of the left or right children. So, we will go to its left children and we will return it. And from node 4, we will go its right children and we will return it. Now, when returning to the node 4, we have seen that the frequency of D in the subtree of this 4 is 1. And here, before returning to this, we have seen that the frequency of the node 4 is not defined yet. So we will increment 1 here, because we have found one of the node D into the subtree of this node 4. Now we have returned from the node 4. And currently we are at this node 1. From 1, we will get back to the 5. Similarly, its left and right children will return nothing. And from 5, we will return the value C with the frequency of 1. And before returning, we will increment 1 into the node 5 position. So 1 will be added here. Now, for this B into each subtree, it has 1D and 1C. So when we return to the or from the B, we will also return the frequency of B with 1. Now, the value B or the node 1 has the value B. So here the frequency of B is 1. So we have to add 1 here into the 1 index. Now we are at this position 0. From 0, we can go to 2. From 2, we can go to 3. Again, when we're returning from the 3, the frequency of E will be 1. And we will add 1 in the index number of 3. Sorry, I have made a mistake. I have skipped the 3 here. So 3 will be added here. Now, when we return from the 3, we are at this position 2. And from 2, we will get back to the 6. And from 6, we will again get back to the 2. And here we will return D with the frequency of 1. And we will add 1 into the 6. That means into this subtree, it has only 1D. Now we are at this position 2. And from 2, in each subtree, it has 1E and 1D. So here, into each subtree, it has 1A. Now, in the index number of 2 or in the node 2, we have only 1A. So we will add 1 here. Now, we are at this position root 0. And from 0, it has 1A into its subtree. But the level of 0 is also A. So here it has 2A. Now we have to add 2 into the index number of 0. And we will return. This is how the problem statement works. And this is how basically the DFS will performs. I hope you understood the algorithm. Now let's move on to the code. Now here we are given a function named count subtrace, which has integer n and the list of edges and the string levels. Now we are taking a global variable or global array and adjacency list, and we are resizing the array with size n. Now here we are building the adjacency list and calling the DFS function with the current node 0 with the current parent -1 and same level. Now here into this DFS, for each of the node, we have to calculate the frequency of each of the character into its subtree. So we are taking a frequency array, which is answer. And for each of the child in the adjacency list of current, if the child is not parent, that means here we are basically skipping the loop. And we are calling the recursive DFS function with the child here. Now here we are storing the DFS function return value into a vector named result. Now here we are updating the answer with the value presented in the result for each of the character. And before returning the answer, we are updating the current nodes value into the array, which is final output, which is the level of current minus a plus 1. Finally, we have to return the answer. After that, when this DFS function will become executed or its completed execution, we will return the array. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.